The fuel tank of this truck can hold exactly 5,351 liters of diesel fuel. Yet not even 1 horsepower produced from this fuel is transmitted directly to the wheels. So, how does this massive truck, with a total weight of 605 tons, move? How can it pull away effortlessly while carrying a 360-ton load on its back? Although the Ballaz 75710 is considered one of its most significant rivals, the Liebherr T284 is actually an unrivaled truck in terms of energy efficiency. So what kind of technology does this mining monster use? When you approach a T284, the first thing you will feel is a deep, high-frequency hum. This is similar to the sound electric cars make when passing by or idling. It is an amazing sight to see a 605-ton weight moving accompanied by this sound. It is like trying to hold your left ear with your right hand. We will share all the details shortly. When you see a T284, you might think its dimensions make no sense. Just one of its wheels is as high as a 2-story house. Its fully loaded weight is equal to the weight of 400 passenger cars. Moving thousands of tons of earth every day and literally changing the geography of the area where they work, these trucks need incredible power. With a powerful diesel engine, you could move even a ship. The high-torque nature of diesel engines is perfect for heavy-duty work. However, it's not just about producing power. You need to transmit a force so great, it could almost twist the crankshaft to the tires in the most efficient way possible. Power from the engine travels through many heavy metal parts, like the clutch, transmission, and axles, before reaching the wheel. This means a significant loss of power. Additionally, the complex structure of the system becomes even more unmanageable under the stress of the carried load. Production costs also increase exponentially. At this point, engineers faced an impossible decision and abandoned that old world where mechanical parts lost energy by rubbing against each other. Instead, they married a massive diesel engine, powerful enough to run a warship, with the world's most sophisticated electric motors. Between the two, they integrated the most efficient coupling system. The massive V20 diesel engine inside the truck produces 3,600 horsepower. To feed this engine, there is a giant 5,351-liter fuel tank. When the diesel engine runs at full throttle, it begins to turn an alternator connected to it. The alternator produces a massive AC current. This electrical current is transmitted directly through cables to the induction motors hidden inside the rear wheels. In other words, there is no shaft or gear connection in the sense we know it between the truck's engine and its wheels. Everything happens solely through the power of pure electrons flowing through massive copper cables. Yes, this technology has recently begun to be tested on standard vehicles. For example, the Nissan brand has taken a serious step in this regard. A standard SUV moving with this technology seems relatively understandable. However, the fact that a 600-ton weight can be moved more easily with this system than with a century-old classic internal combustion engine system breaks all taboos. We continue to share the special technologies of the world's largest machines with you. You can subscribe to our channel so you don't miss new videos. If there is a machine you want us to review, you can let us know in the comments. The true genius at the heart of this system lies in the IGBTs, called insulated gate bipolar transistors. These are actually the switches in the truck's massive nervous system, and they manage the electric current so precisely that they allow the 600-ton truck to move centimeter by centimeter. That jolt felt when you release the clutch in a normal truck never happens in the T284. Electric motors provide maximum torque right from 0 RPM. The powerful induction motors located exactly inside the rear wheel can move the truck as easily as a toy car, thanks to minimum energy loss and maximum torque. When efficiency was the main point and electricity was the hero of the story, engineers took it to the next level. A system was added to the truck that turned the Liebherr T284 from an ordinary giant truck into a train without tracks, in every sense of the word. In this system, called Trolley Assist, the truck draws energy from high-voltage lines, just like trams in the city. On the truck's operating route, especially on steep slopes, massive steel arms, pantographs, on top of the cabin touch the high-voltage lines. The moment the electric current from the high-voltage line reaches the truck, the diesel engine shuts down, and the truck continues with the electricity it receives. This provides immense savings on steep hills where fuel consumption is highest. Additionally, the life of the diesel engine is extended. Standard T2-84 models do not have a battery unit to store energy. It works on a produce and consume logic. Either the electric current produced by the diesel engine or the current taken from the high voltage line is transmitted directly to the induction motors. Liebherr is working on fully battery-powered or hydrogen models for the future, but there is no battery system in the standard T2-84 models currently in operation. In connection with the battery, the braking system is also a rare example of its kind. For machines of this weight to stop, extra systems are required alongside the classic braking system. The retarder system is used in many vehicles such as buses, trucks, and semis. It works with oil pressure and helps the wheels slow down. In fact, over time, retarder technology has developed so much that drivers can often operate these heavy vehicles without using the brakes. If you have driven an electric vehicle, you know that when you take your foot off the accelerator, the vehicle slows down and charges the battery, even if only a small amount. This is a brilliant system that affects brake wear and driving range in electric vehicles. You might have thought that the Liebherr T2-84 also provides its power with electric motors and could increase its efficiency by using these motors. You are partially right, but there is a difference. As the truck goes downhill, the moment the driver takes their foot off the gas, the electric motors in the wheels start working in reverse and turn into generators. In this case, what slows the truck down is not physical friction, but electromagnetic resistance. The wheels continue to turn while generating electricity, and this production process actually acts like a giant magnetic brake that steals the truck's speed. We mentioned that there is no battery system in this truck. In any case, the electrical energy produced during braking is so immense that it was almost impossible to store it in a battery with the technology available in those years. Therefore, there are massive resistance grids on the truck called the retarder grid. The current of thousands of amperes coming from the motors, which have turned into generators, is sent to these grids and converted into pure heat. Huge fans kick in to cool these grids, and the column of hot air rising from the top of the truck toward the sky has enough thermal power to heat thousands of homes. Thanks to this system, the T2-84 can safely descend miles of long mine ramps without stopping and without touching its mechanical brakes. While traditional trucks have to wait on these slopes to cool their brake pads, the T2-84 continues to descend safely, radiating heat like a barbecue. This giant truck, which needs thousands of kilowatts of energy to move, can throw away a significant amount of electrical energy just to slow down. One of the most striking features that sets the T2-84 apart from its competitors is its modular structure. This truck is not produced in a factory and sent to the mine as a whole. It is transported in pieces by giant semis and assembled at the mine site in an operation that takes weeks. The giant engine, alternator, chassis blocks, and cabin are joined together like pieces of a puzzle. This process is like an engineering ceremony involving massive cranes and dozens of technicians. Once it stands up, the T2-84 will spend the rest of its life working day and night in that mine pit with the power it gets from electrical energy. While the fossil fuel versus electric battle is just starting today, Liebherr engineers produced the most efficient system about 14 years ago. By bringing together the independence of diesel fuel and the high efficiency of electrical energy, this giant that dances in mine sites was born. See you in a new video where we talk about the unique technology of another massive machine.